Okay, so we got a lot going on here. Oh my goodness. It says segment AB is congruent to segment BC. Segment DE bisects segment AB, and segment DE bisects segment BC. Whoa. And we got to prove that segment BD is congruent to segment BE. Okay, so let's talk about what we got going on here. Okay, so first of all, right, we know that these big long segments are congruent. So segment AB is congruent to BC. Okay. We want to prove that these two segments, BD and BE, are congruent. Okay. So somehow we have to get rid of AD and EC. However, they give us this extra information. They tell us that DE bisects both sides, right? It bisects AB and it bisects BC. So what that means is bisecting means I go through its midpoint. So this segment is congruent to this segment, and this segment is congruent to that segment. And because the original big sides are congruent, each of these smaller parts is congruent, and boom, I have these two being congruent. So now the question is, how do I prove that? When I did this, I did a big, long 8-step proof involving segment addition, because that's what I thought it was. But I saw their answer, and there's a trick. So I will show you that trick. What does bisect mean? Right? Well, bisect means splits in half. But there's a couple other definitions as well. Bisect also means that you can be half of something, or something is 2 times you. So since we want to focus on segment BD, let's talk about segment BD, right? Because, I'll go back to my pen, because segment DE bisects AB, that means this segment and this segment are congruent, which means that BD is half of AB, because two of them make the big long segment. So BD, I'm sorry, I wish my pen could show that better. Here, I'll try. BD is half of AB. Okay, so we're going to write that down. All right, that'll be my next step. So over here. So I'm going to say that. So here we go. A segment length is half of something or 2 times something. So I'm going to go ahead and set, because I want to focus on BD, BD is half of segment AB. And the reason is when a segment is bisected, each part is half the length of the whole segment, right? So it's the idea of being bisected. And you can see there's a whole bunch of different options when you're doing that. Okay. I'll do the same thing with the other side in BE. And again, it's only because I want to prove that BE is congruent to BD. So BE is also half. So BE is also half of BC. Same reason, whole segment cuts it in half. So now, if we look up here, well, AB, segment AB and segment BC are congruent. Well, BD and BE each equal half of those congruent segments. So therefore, BD and BE should be congruent to each other. And let's see if I can do that. We'll see. BD and BE are congruent. Let's see what we got. Okay, if we scroll down here, congruent segments added. No, segments that are half the lengths of congruent segments are congruent. And there we go, right? I knew there was an option. Segments that are half the lengths. So each of these, BD and BE, are each half of AB and BC, but we were given that AB and BC are congruent. And there's my green check mark. Submit. So again, like I said, my first one was 8 steps long, but I got it right. All right, but this is the shorter one. And again, you can see the markings down here as they go. Okay. All right, last problem. Okay, so this one says angle ABD is congruent to angle BDE, and those are marked here, ABD and BDE. We want to prove that angle CBD is congruent to angle CDB. All right, so let's draw some things on here, right? So these two angles are congruent, so this angle and this angle. We eventually want to prove that these two angles are congruent here and here. So the question is, what do these angles do together? Well, if you look here, right, I'll use a different color. here is segment AC. Here's my segment going off, right? Linear pair. Angle 1, angle 2 form a linear pair. They'll add up to 180. Same thing on the other side. I'll use green. So here's a segment. Here's this ray going off. Angle 1, angle 2 there, linear pair. So think about this, right? If those two bottom angles are congruent and the two top angles are both linear pairs, which means they're supplementary to the bottom angle, then those two top angles also have to be congruent. So again, for instance, if this angle was, say, 120 degrees, well, then this angle is 120 degrees. And if these two angles are a linear pair, they're supplementary. This is 60 degrees, 180 minus 120. And so is this because it's also supplementary, to 120. So this should all make sense. So this is the idea again of a linear pair. Linear pair. So let's write it down. Again, if it's confusing, I get it. All right, and I'll explain what your homework assignment is going to be after I'm done. All right, so next, we're going to say that angle ABD and angle CBD are a linear pair. They're supplementary. Angle ABD and angle CBD are supplementary. That's because if two angles form a linear pair, they are supplementary. Let's do the same thing with the other side with BDE and CDB. CDB. Same reason. And now, again, angles CBD and angles CDB are both supplementary to congruent angles. So again, if those angles are 120, CBD and CDB are both 60, that means they're also congruent. So I think I can say that these angles are congruent. CBD, CDB. Let's see what we got here. If two angles are complements, no. If two angles are supplements of the same angle or congruent angles, they are congruent. There we go. Try it. Yes, green check mark, and I'm feeling good. Check it. Yes. All right, so when you do your Delta Math homework, I think you'll see that the 4 problems you have to do are familiar to the 4 problems we just did. So my goal for you is just to see if you can try to piece them together on your own. And again, we're just developing your sense of proof writing. All right, best of luck. Ask me for help. I would love to help talk you through proofs.